Hello everyone, welcome back to my YouTube channel. This is Mr. H. In this video, I will be discussing how to calculate the volume of different 3D shapes. So this video will focus on calculating the volume of sphere, cylinder, cube, cuboid or rectangular prism, prism, and compound or composite solids. So let's jump to the very first example. So the first example is calculate the volume of sphere given its radius of 5.5 centimeters. The formula in calculating the volume of sphere is 4 over 3 multiplied by pi multiplied by r cubed. So 4 over 3 pi r cubed. So r there stands for the radius. And if you take a look at the given problem, so the radius, which is 5.5 centimeter, was given. All right, so to calculate this, what we need to do is to simply plug in the measure given or the length of the radius, which is 5.5 centimeter, to the formula. So we're gonna have 4 over 3 times pi times the radius is 5.5 centimeters, so we just substitute that. So the volume of sphere will be equal to, for this question, whenever you calculate the volume of a certain 3D shape, in order for you to get the most accurate answer, so first of all, you need to consider what the question asks you to calculate, or how you need to present your final answer. So if the answer must be presented in, in pi form, because there are questions when you will be asked to write your answer in pi form, or not with pi, or the other way around. All right, that's the first tip. The second tip is there are cases when you will be asked to use 3.14 for pi. Others give 22 over 7 for pi. And if there's nothing mentioned in the question, which value of pi would you need to use in calculating the volume? So what you need to do is to just use the pi itself on the calculator. If you look at this part right here that I circled, if you want to get the most accurate answer for the volume, you need to type in one single string of numbers. Then it will give you the value, and that's when you round up the number. It depends on what the condition is in the given question. So if you type on your calculator this, it's going to give you 1331 over 6 pi centimeter cube. That is the answer in pi form. So the other answer, which is the standard answer, this is going to be approximately 696.91 centimeter cube, or cubic centimeter. All right, let's head on to the second question. Calculate the volume of the solid. Leave your answer in pi form. So as you can see, so the diagram is given on the right. By the way, the the figures are not drawn to scale. All right, so we just take a look at the given measurements and the unit, and we follow. That's what we're going to use for our, calculation. All right, the figure on the right. So there's part in the middle of the solid that's taken out of it. So basically, it will affect the calculation or the final volume. So what we need to do here is we need to calculate the volume first of the bigger cylinder, which is the one outside. After calculating that, we will calculate also the volume of the cylinder inside, but that was actually taken out of it, right? And if we want to find the final volume or the volume of the solid, we need to take the volume of the outer minus the volume of the inner, so that we'll get the volume of the actual solid. So the volume of the cylinder is calculated using the formula pi r squared times the height. Let's calculate first the volume of the first cylinder. So volume of cylinder 1 would be equal to pi multiplied by the radius squared. So the radius is 5 centimeter because this is diameter of the base, which is 10 centimeters. So the radius is half of it. So we have 5 centimeter squared times the height of the cylinder. The height is 7 centimeters. Then we continue with simplifying. So volume of cylinder 1 will be, this one is pi, then we will have 25 centimeters squared times 7 centimeters. And 25 times 7 is actually 175 pi centimeter cubed. So that is the volume of cylinder 1. Remember, the question asked you to write the final answer in pi form. So for the volume of the first cylinder, I left it in pi form. So after calculating the volume of the first cylinder, so we can calculate the volume of the cylinder 2 following the same formula. So we've got pi radius squared times the height. So volume of cylinder 2, we've got pi and the radius. So again, the diameter is 3 centimeters and the radius is half of it. So that means it's 1.5 centimeter times 7 centimeter for the height. All right, then we simplify. So pi, so 1.5 square is 2.25. So 2.25 centimeter squared. So you are also squaring the unit times 7 centimeters. And from here, we can just simply multiply to get the volume of cylinder 2. And the volume of cylinder 2 will be pi times 2.25 times 7 times centimeter squared, and centimeter is 15.75 pi, don't forget the pi, and then centimeter cubed. So to find the volume of the solid, volume of the cylinder 1 minus the volume of the cylinder 2 will be equal to 175 pi centimeter cubed minus 15.75 pi centimeter cubed. And the answer is 159.25. So 159.25 pi centimeter cubed. That is the volume of the solid. So let's move to the third question. If the volume of the solid is 1,331 cubic meters, find the value of x. So the diagram tells you that it's a cube and we're looking for the value of x, which actually represents the length of the edge, right? And you can see all these markings right here. That means that, it's a cube. So basically, the length of this and that one are the same. So if one of them is different, definitely it's not going to be a cube. Okay. So, and we were also given the volume of the solid, which is 1,331. So we have volume of cube will be equal to side cube, or S cube. So S represents the side, the length of the side. So what we need to do is to simply plug in the given information to the formula. So volume of cube is 1,331. And we know that S is the length of the side, which is here represented by uh, X. So it's going to be X cubed. All right. And so from here, you are given this equation. You have 1,331 equals X cubed. So since the power here of X is 3, we need to take the cube root of both sides. And since you're dealing with an equation here, whatever you do on the left, you must also do on the right. And here, to simplify this, so you got cube root of x cubed. So basically, that's when we will get x. And here, you've got cube root of 1,331. And the cube root of that is a perfect cube. So the cube root is 11. So basically the value of x is 11, and relating it again to the given diagram. So we're looking at 11 meters is the length of the edge. All right. So that's for question number 3. Let's move to the fourth question. All right, so fourth question, the volume of the cuboid is 210 cubic centimeters. Using the other given measurements, find the value of x. So we're given the diagram here. So cuboid or rectangular prism. And you're given this measurement, which is 15 centimeter right here. You got 6 centimeter here. But this measure represented by x is what we need to calculate. We were given the volume of the solid. All right, so if you can recall the formula in finding the volume of a rectangular prism or cuboid, so the volume or the formula is the length times the width times the height. And as you can see from the given diagram, we're actually missing one, which is the height. Even if you interchange the length and the width, it won't matter because the operation here is multiplication. So whether you plug in 15 centimeters for the length and 6 centimeters for the width, or vice versa, it's not going to affect anything because the operation here is multiplication. So whether it's 15 times 6 or 6 times 15, it will give you the same product. All right, so going back, so volume of cuboid is equal to the length times the width times the height. And then again, we were given the volume already. So we can say that the volume, okay, 210 centimeters cubed. And then we plug in the other given information. So we have 15 centimeters, say for the length, and for the width it's 6 centimeters times the height. Or we can change the h, replace it by x. So we carry on simplifying the right hand side of the equation. So the left hand side is already fine. So we got 15 times 6 is 90. Centimeter times centimeter is centimeter squared. Remember the x there. So it's times x. From here, you can see that we can solve for x already, right? So if we want to solve for x from this stage, we just simply need to divide both sides by 90 centimeter squared. 90 centimeters squared divided by 90 centimeters squared will be 1. So it's going to be 1x or x. So 210 centimeters cubed divided by 90 centimeters squared. So it's going to give us 2.33 centimeters. So remember, if you're dividing centimeter cubed by centimeter squared, there will still be one just centimeter that will be left. That's the unit. So the answer, oh, it's actually, approximately 2.33 centimeters. So again, like what I mentioned earlier, you always need to follow what the question asks you to do. So here I left my answer in two decimal places. So then again, sometimes the question can be rounding it up to whole number or writing your answer in one decimal place and stuff like that. So that's what you need to follow. Okay, so that's for question number 4. Let's have a look at question number 5. Calculate the volume of the prism. All right, for this example, I want to highlight one thing, the term cross-section. Volume of a prism will be equal to the area of the cross-section multiplied by the length. Going back to the term cross-section. So what is a cross-section? So cross-section is the two-dimensional shape obtained by the intersection of solid by a plane, right? So imagine this. This is actually a triangular prism, right? Imagine if you cut this solid using a plane, say a cutter that is flat, right? So if you cut it from here, you will definitely see this face, right? So the cross section is actually this one. I'm coloring green. That is the cross section. So again, if you try to cut the prism using a flat cutter, for example, and you cut that, you will see this triangle, right? Repeatedly after cutting the prism. And why do we need to take note of what the cross section is? Because it will play a vital role in calculating the volume of the solid, like what I already mentioned earlier. So to find the volume, you need the area of the cross section multiplied by the length. And the cross section can be different. It can vary. So for this prism, it's a triangular prism. So basically, you know that the face, this face, which is the cross section, is a triangle, you need to calculate the area of the cross section. Whatever the area is, you will multiply it by the length, and that will be the volume of this triangular prism. It is also applied to other prism, because maybe some of you are more confident in not memorizing the formula, but by just taking note of how the volume is calculated, provided that you have the knowledge of how to identify a cross section, and you'll be able to calculate the volume of whatever prism is. I'm not going to erase that, so I'll just leave it there. So let me write the solution down here. All right, so I already mentioned that the formula is area of the cross section times the length. All right, so the cross section here is a triangle. And so everyone's familiar with the area of a triangle, right? So it's base times height divided by 2, or 1/2 times the base times the height, okay? Is going to be 1/2, or 1/2, times the base, which is 17 centimeters, times the height, which is 9 centimeters, times the length. The length is 25 centimeters. Volume of 1912.5 cubic centimeters. All right, so that's all for question number 5. And on to our last question. Calculate the volume of the solid. Calculating the volume of this, we're actually going to apply the cross section again here, right? So you can see this one. Sorry about that. Which is actually the cross section. And if you take a look at the cross section, it is composed of a rectangle and a semicircle. Okay, so the area of the cross section will have the area of the rectangle plus the area of the semicircle multiplied by the length, which is 11, which that will be the the volume of this whole solid. All right, right. So let's solve for it. And again, the area of the cross section. The cross section is composed of uh, two 2D shapes, right? So we have the area of rectangle plus the area of the semicircle times the length. So you know the area of rectangle is length times the width. And the area of semicircle is technically half of the circle. If the area of the circle is pi r squared, then it's going to be pi r squared divided by 2. For the area of rectangle, we have the length times the width. So you can take a look at the diagram again. So the length, okay, so we have 4.5 centimeter times 8 centimeters. So here, so 8 centimeters times 4.5 centimeters plus area of semicircle. So you can see the markings right there. You can see these markings, right? So those markings tell you that they are the same. If the whole thing right here is 8 centimeters, definitely this one is going to be 4 and 4, and that's going to be 4 too. So the radius is 4 centimeters. Okay, so we take the formula again. So we have pi, so divided by 2. So the radius is 4 centimeters. So it's going to be 4 centimeters squared times the length, which is 11 centimeters. So we simplify first what's inside the bracket. So 8 centimeters times 4.5 centimeters is going to give us 36 centimeters squared, plus, so 4 squared is 16, divided by 2, it's 8. So it's going to be 8 pi centimeters squared. So you also need to square the unit. So centimeter, it became centimeter squared. So you got times 11. And again, typing all of them in one go on your calculator, it's going to give you the volume of the solid will be equal to, this is approximately, I'm sorry about that, 672.46 centimeter cubed. That is all for this video. I hope you learned something. And if you learned something new, please remember to like this video, leave a comment below, and please remember to subscribe to my YouTube channel if you haven't subscribed yet. All right, again, this is Mr. H, and thank you very much for watching.